Your Chapter 3/Unit 2 exam is on Monday. So we have today in class to review. And then Monday's your exam. You have over the weekend to review as well. I am happy to go over any problems from the review. After school today, I will post my answers for all the review questions, including the work. So you can check your answers against mine. And you can also, if you made a mistake, find your mistake. Okay? If you guys want me to go over any of these questions, I'm happy to do that now. I'm happy to go over any homework problems. I'm happy to go over anything that you guys want to know or see from this unit, from this chapter. What do you guys want to look at?
I don't even know how to say it. So like the x with
the step function?
Yeah, the step function.
Absolutely, yes. All right, so question number 2. This thing right down here is a step function. Remember, this is the one that looks like this, right? And that should look a little bit better. It's closed on the left, it's open on the right, all the way up. What has happened to this step function, though? What's that -4 tell me? Down 4. I'll worry about those fences in just a minute. Let's just talk about the step function because we can go back and erase anything that's not where it belongs. Okay? Step function normally starts right here at 0, 0, and it goes over to 1. It has an open circle. You're welcome. And then it would go up from there. It's really hard to see that that's an open circle, but I promise on the right-hand side it's open. But we've taken this and shifted it down 4, right? That's what that -4 means. So I would take this and go down 1, 2, 3, 4. That first step should be right there. And then I would have another step right here, and another step, and another step. All the way until I run out of room to put steps on here. You guys okay with what that looks like so far? Now I'm looking at that fence. Where does it say the fence is? Greater than or equal to 3. So at 3, 1, 2, 3, that would be right here. And because it's greater than or equal to 3, I need to erase some because it's not going to be on both sides. It's only going to be on one side of it. Which side do I keep? Right side, because it said greater than or equal to, right? So I'm going to go back in and I'm going to erase this part out of here. Since it's got that or equal to, I keep the closed circle there. You guys all right with that so far?
And what's the range of that?
What is the range of that? So that one, the range is all integers. That's one way that you can write integers. So when we go to do the range part of this function, I want all integers that are bigger than 3 for that part. Let's do the other 2 functions here so then we can talk about domain and range on this. But I know when I get down here to the range, we've got, it looks like -1, 0, +1, +2, +3. I'm going to go ahead and write those in, but I'm not sure that that's my final range yet because I don't have the other functions up there yet. So I see -1, I see 0, 1, 2, 3, and then it just continues on with all of those integers there, right? So I can just kind of put a dot, dot, dot. As long as anybody else looking at this can follow that pattern, once I've established that pattern, I can just put dots.
Ms. Bo,
Yes, sir.
is there a way to confirm the step function without like erasing?
Yeah. But I still, like, even though I don't erase, I would still put my pencil there. So instead of doing the erasing, I would hold my pencil like at 0, 0 and be like, okay, that's where it would start. And then from there, I would take my pencil down, 1, 2, 3, 4. And I'd go, okay, here's where my first step would be, but I know it's not really there. My next step would be above that. And I would like pretend draw on my graph until I get to where it starts. Yep. So you can absolutely do it without erasing, but I don't know of a shortcut way personally where you could do it without like tracking what it would be. Where else do we have a fence for this? For this whole piecewise function? -2. So I'm going to go ahead and draw that one in. And what function lives in here, in between those two fences? -2x plus 3, which is what kind of a function? Linear. So I'm going to start it at 3 on the y-axis, and I'm going to use my slope of -2. So down 2, right 1, down 2, right 1, down 2, right 1. Here it does not own this fence, so it gets a big open circle there. When I go backwards, it does own this fence. Please, 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 please do not just leave these as dots. This is a line. Connect your dots. Will you lose points for not connecting your dots? Yes, you will. So there's that guy. Here's the reason why I kind of held off on that range stuff. Because I see that this is going up higher than that, right? But my step function doesn't stop just because my graph stops, right? It would continue going. So I see that this one goes up to, what is that, 7? So my step function would still go 8, 9, 10, 11. So I'm going to kind of modify what I have as the range for this. 8, 9, 10, 11. It would keep going after this point. And then we got this guy up on top. What shape is that? A parabola. Where is the vertex of that parabola? -4, -2. Can I put the vertex in the section where it lives? Yes. -4, -2. So here's my vertex. What else do you know about this parabola?
Downwards.
It's opening downwards because of that negative out in the front. I need to use what I know about the parent so that I don't have to do a whole table for this, right? Is it stretched or compressed at all? No. So from the vertex, if you think about the parent function, as we move to the left and to the right, as we change in the x direction, if I move 1 to the right, I take that and do what to it? Go up 1, because we're going to take it and square it. Y = x squared is my parent function. So I would go right 1 and up 1, left 1 and up 1. But this has been reflected. So am I going up? We're going to go down. So I'm going to go right 1 and down 1, left 1 and down 1 from my vertex. Right 1, down 1, left 1, down 1. We good so far? Go back to your parent. If you move 2 units away from the vertex, we're going to take that and square it. What's 2 squared? 4. Since it's been reflected, am I going up or down? Down. So I'm going to go 2 units to the right and then down 4. 1, 2, 3, 4. That's going to be an open dot there. I move 2 units to the left and I go down 4. 1, 2, 3, 4 right here. That would be enough points. Oh, sorry, I took him down 1 too far. 1, 2, oh no. He was on the right spot. My open circle is 1 up too high. That's what happens when I zoom in too close. I can't count right, apparently. You guys okay with where those dots are? Can you see that parabola shape? My first set of points should only be 1 unit down from the vertex. My second set of points should be 4 units south of the vertex. Sorry, I've been teaching absolute value to my Algebra 2 kids, so we're talking about like north and south with directions. All right. Let's finish out that range now that we got the whole thing on there. What is the smallest range value we could get? Negative infinity, because I got one end pointing down, right? So I've got negative infinity. The parabola goes all the way up to where? Negative 2. Do I have an output value of negative 2 over here?
No.
Yeah, on that linear function, I have an output value of negative 2. And I can follow that up to where?
7.
Up to 7. So from negative infinity to 7, there's an output value everywhere in between there. I might have to skip where I'm at on the x-axis, but there's an output value somewhere along that horizontal, up until 7. I can get up as high as negative 2 here. This one starts at negative 3 and goes up. Anytime I see connected dots, no matter what shape it's making, that means there are output values all along there. Yes, ma'am? That's my step function here. Because even though my graph stops here, I know the steps wouldn't stop. So where would that be at? Let me show you. This step function would continue on.
So wait, you just put the numbers after 7, that's why you started with 8?
Yep. Yeah, because there's nowhere on here that I have any kind of line that runs in between the 7 and the 8 vertically.
So if it's like that, you wouldn't, like where you put 8, 9, 10, 11 for the range of the step function, you wouldn't put any number lower than 7 again?
Correct. Because here I have a range value of 7, but then I don't have anything in between the 7 and the 8 until I get all the way to 8. Same thing between 8 and 9. I don't have any kind of output. There's no kind of vertical output at all in between the 8 and the 9, or in between the 9 and the 10. You guys okay with that? Let's go ahead and talk about our domain here. What would my domain be for this? Yes, sir.
I'm sorry.
No, you're good.
I don't understand why it can't just be all real numbers, because
For my range?
yeah, because it goes all the way down.
Mhm.
For the step function, it goes all the way up. Keeps going, right?
Sort of. Step function doesn't go all the way up. It continues on, but the output, which is what I look at the horizontal for, do you see how it's flat for each step?
Yeah.
So when it's flat like this, that's a constant output value. There is nothing that I could put in for x and get an output of 8.5. Because nowhere on here, if I look between the 8 and the 9, that would put me in between these two steps. I'd like slip through. There's nothing that I could put in for x into any of these functions with these barriers in place that would give me an output value of 8.5. That's why I have these numbers listed out individually, because I can get an output of exactly 8, but I can't get 8.2. I can get an output of exactly 10, but I can't get 10.9. Does that make sense? That's why I list them out individually. If you've got connected dots between things, I don't know what the X value is, but I could put something in here and get an output of 4.7. So that's why that part of the range runs together. Does that make sense? Domain. All real numbers. I've got an arrow over here. It's tipped slightly out to the left. It would continue on and on and on forever. So I can get any kind of negative as an input. Everything in here up to here. Can I use -2 as an input? Yeah. The one up here. I can't put it into this function, but I can put it into this function, right? And I've got every X value in between until right here. Am I allowed to use 3 as an input? Yes, in this function right here. Can I use 4 as an input? Mm-hmm. Could I use 7.2 as an input? Yes. 7.2, that would be here if I follow that up. There is a continuous piece right there. So I've got any kind of number I want to on my domain. -infinity to +infinity. Do you guys notice any discontinuities on this? At -2, what kind of discontinuity do we have? Jump. So there's a jump at x equals -2 and at x equals 3. Technically speaking, are there any other jumps? Yeah, my step function is full of jumps. I would have to jump each time. So we have jumps at x is like 4, 5, 6, all of those after that. I'm not going to ask you to list them all out. But I do want you to recognize them. And I got to get this out of the way of my domain there. So there.
Are we gonna have to state jumps on this?
If you have to state jumps, I promise not to do it on a step function. If it's a jump, it would be something like this guy. That's what I'm going to ask you for. What else do you guys want to talk about? Tommy, did you have any questions?
How do you do the,
Pedro, you had your hand up?
Oh, no, you can go.
Just tell me which one so I know what we got on deck.
There's a few.
Okay.
I think we do number 10.
Number 10. Caleb, what do you
I
want to
just
talk
want to
about?
know the absolute values on
Absolute value, like on the first one?
the, yeah.
Does that one have an absolute value?
Well,
Oh, yeah, it does. I see it now. Yeah, we can talk about our absolute value. And then we'll go do number 10. So absolute value is a lot like a parabola. So it's got a vertex. Where would the vertex of that be? -1, -7. So I can put that on my graph. -1, -7 right here. What does an absolute value function look like? A V. For this one, when we talk about our V, as I move to the left and to the right, however far I move to the left and to the right, that's how far up I would go, unless it's reflected, and then that's how far down I would go. So from that vertex, from that point, if I move 1 unit to the right, I should go up 1, right? 1 unit to the right, up 1. If I go 2 units to the right from the vertex, I should go up 2. 3 units to the right from the vertex, I should go up 3. 4 units to the right of the vertex, I should go up 4. What about as I move to the left? Yep. Left 1 up 1, left 2 up 2, left 3 up 3. I want to do this all the way until I get to where? -6 on the x-axis, because that's where I would have a fence, right? So this is what our absolute value function would look like. Filled in dot over here, because it owns that fence. Open dot on the other side, because it doesn't own the other fence. Does that make sense, Caleb? Okay. Number 10 was the next one we were going to go and look at. Oh, yes. Find the center and the radius of the following circle. So I want to put this into standard form. Because standard form is what shows me the center and the radius. What is standard form for a circle? We've got a y. What happens with our y?
Square.
It's going to be squared. We have r squared.
So it's like
X minus
minus
H squared.
X1.
There we go.
Plus,
X
y
minus h
minus
squared.
K equals R squared.
Yes. You do need to know this for the test. Please know your standard form for a circle for the
I
test.
think you wrote down 2 Y's for the one.
Thank you. I did. I meant to write K. There we go. All right. We okay with that? This is what I have to get this thing to look like. So what am I going to need to do with this? Yeah, we're going to need to complete the square. How many times? Twice. We're going to complete both squares. So I'm going to group my x's and I'm going to group my y's. What do I do with anything that doesn't have an x or a y?
Put it on the right side.
Yep, kick it over to the other side. So I'm going to subtract 41 from both sides. So I'm going to have 4x squared plus 24x. I'm going to group those together. Plus, and then I have 4y squared minus 16y. Group those together. Equals -41. You guys okay with that so far? Am I allowed to have a coefficient in front of my squared terms? So how do I deal with it? Divide. We're going to kick it out to the front. I'm going to divide both of these by 4, and that's going to kick to the front here. So 4x squared plus 24x plus something.
Plus 6x.
6. Oh, thank you. I said divide, and then I didn't. We're going to kick this 4 out to the front as well. So I have plus 4, and then y squared minus 4y plus something equals -41. How many things are we going to add over here? 2. 1 for each square that we're completing. If there's something that I kick out to the front, I have to put that on these lines. How do I figure out what we need to put on those lines?
You do B divided by 2 squared.
Yep. B divided by 2 and then square it. So what's going to go here? 9. I put that back here as well. What about the other one? 4. I'm going to put that back here. Are we good so far? Awesome. So I have 4, and then what will I get when I factor my x's?
X plus 3 squared.
X plus 3 squared, plus, and then I have a 4 here. What will this be?
Y minus 2.
Y minus 2 squared Over here, I'm going to have negative 41 plus 36 plus 16. What does that give me? 11. Standard form. Do we have something in front of the parentheses in standard form? So how do I get it gone? Divide. We're going to divide both sides by 4. So I divide this by 4, I divide this by 4, I divide this by 4. So I end up with x plus 3 squared plus y minus 2 squared equals 11 over 4. Where is the center? Negative 3, positive 2, right? What do I have to do to the part after the equal sign to find the radius? I have to square root it. So my radius is going to be the square root of 11 over 4. How do we square root a fraction? Yes, we're going to square root the numerator and square root the denominator. Are either of those perfect squares? 4. What's the square root of 4? 2. So 2 is my denominator. Can I take the square root of 11?
No.
Can I simplify it at all?
No.
Nope. Have I rationalized the denominator? Yes, it was a perfect square, so I don't have to worry about that. Here's my radius.
Plus or minus.
No plus or minus. Because when we're talking about a radius, we're talking about a distance away from the center. And anytime we're talking about a distance, it can only be a positive thing. That's a great question. Every other time we do square roots, you do have to remember that plus or minus. But when we're talking about distance, you don't have to. Pedro, you said there were several. What else did you want to see?
Oh, yeah. Number 3.
Number 3, absolutely.
Part
Part A. Talking about the domain. So domain means I'm talking about what values? X's. Domain is all allowed X's. When I'm thinking about a square root, what has to be true about the part under the square root?
It has to be positive.
Has to be positive or 0. No negatives. Positive number is 0. So I would do 2x minus 3. I want that to be greater than or equal to 0. Then I need to get the x all alone so that I know what values for x I'm allowed to use. So if I add 3 to both sides, 2x is greater than or equal to 3. So x has to be bigger than or equal to what?
0. Oh,
1.5, 3 over 2. So my domain, I need to write this in interval notation, and I have to explain that x has to be bigger than or the same as 3 over 2. Yes. Absolutely. What else did we want to talk about?
Can we go for B?
Absolutely. When I have a fraction like this, what am I not allowed to do?
0.
Where? Denominator. So the denominator cannot equal 0. So I'm only focused on this part right here. X squared minus 2x minus 24 cannot equal 0. What do I need to do with that thing to figure out what values for x are not allowed? Factor it. What two numbers multiply to negative 24 and add to negative 2? Negative 6 and 4. These are the things that I cannot have equal to 0. So that means x cannot be what? X cannot be 6, x cannot be negative 4. Are every other value for x okay? Yes. So I need to write this in interval notation. My domain. How do I explain that I can use everything but these numbers?
All real numbers. I mean, yeah, and then the squiggly ones, and 6 or negative 4 comma 6.
That would work unless it says I have to use interval notation. If it says you have to use interval, because what you just wrote is correct. Now, how do I take that idea and write it as an interval? Negative infinity to negative 4. And then 6 to infinity. Yes. And why do we use parentheses here instead of brackets? Can't be equal to. I can't touch it. Bracket means I'm allowed to touch it. Parenthesis means I'm not. That's how you need to write it. And because the directions here do say interval notation, we have to write it that way for these. What else did you guys want to talk about or look at? C? Absolutely. Do we have an arrow on this end? No. Is there a very obvious open circle there? No. So if there's not an obvious open circle, we assume it's closed. The only way I can know that it's an open circle is if they make it really, really clear that it's an open circle. So what is the smallest x value that would work? Negative 4. Am I allowed to touch it? Yes. Where does it stop on the right-hand side? It doesn't, right? It's got an arrow that seems to be pointing down, but it's also slightly tipped out to the right. So it would continue slightly tracking out to the right forever and ever and ever. We can get to infinity this way. What other problems do you guys want to look at?
Can we do number 9?
Number 9, absolutely. All right, so we're going to use our difference function, or sorry, difference quotient. Here's my function f of x. So up on top, when it says that I want f of x minus, or sorry, f of x plus h, that means I'm going to sub this in for x. So I would have 3 and then x plus h squared plus 4 minus f of x, which would be 3x squared plus 4, all over h. Why do I have parentheses around the red part?
Because it's being subtracted.
I'm subtracting that whole thing, not just one part of it. I'm subtracting the whole function. Please make sure whenever you have a subtraction sign, if you substitute something in after that subtraction, you put parentheses around it. I need to clean this up so that I can see things that are going to cancel. Where do I start on the blue one? Distribute.
The 3.
Is that what comes first in my order of operations?
Oh no, you got square.
We got to square it first. How do we square a binomial? Double distribute. So we're going to square the first piece. That would give me what? x squared. We're going to square the last piece, h squared. What do I do for the middle part? Multiply them together, then multiply it by 2. So I do x times h times 2. So 2xh. Minus 3x plus 4. All over h. So far, so good? Now I can do what? Now I can distribute. How many places do I need to distribute? 2. I have to distribute the 3 here. And what else do I need to distribute? The negative. So I'm going to have 3x squared plus 2xh. Sorry, not 2, 6. 6xh plus 3h squared plus 4 minus 3x squared minus 4 all over h. What can I do now?
Cancel out like
Cancel out like terms. What are the like terms that I can cancel out? 3x squared and the 4. So I'm only left with what?
3xh plus 3h squared.
Yep. 6xh plus 3h squared all over h. Can that simplify any more than that?
Yes.
How?
Take out the
H.
You like take out an H and then cancel it out.
Yes, I can take an h out and cancel those out. I can also take what out? A 3. Does that help me reduce my fraction at all, though? Then I'm not going to take the 3 out. I don't want to factor things out. Anytime it says fully simplify, I don't want to factor things out unless it's a fraction and it's going to help me reduce it. So I'm only going to take the h out. That would leave me with 6x plus 3h all over h. Do I have 2 factors that are the same? Yes. So I can cancel those h's, and that would leave my final answer as 6x plus 3h. Yes, Caleb?
I was just, when you take out the H,
Mm-hmm.
I put it like, I took it out of the denominator too. Wait, this is wrong, but like I took it out of the denominator too. So I put it as like H and then parentheses 6x plus 3h. And I mean, that was what I left it as, and I just left the 1 at the bottom.
Oh, yeah, you got to cancel those h's out. Because we want it fully simplified, and that means if anything can reduce, we have to reduce it. Did you guys want to see part B as well, or no? Yep, okay. So I need an enormous fraction for this, because what are we putting in the place of x for the first part? X plus h. So I'm going to have x plus h squared minus 5 times x plus h plus 4 minus, and then inside parentheses, because anytime you write subtraction and something goes after it, you need to put it inside parentheses. X squared minus 5x plus 4 all over h. We already know how x plus h squared is going to expand, right? What is x plus h whole thing squared?
X squared plus 2x plus
X squared plus 2xh plus h squared. And then I would have minus 5x minus 5h plus 4 minus x squared plus 5x minus 4 all over h. Tell me how to clean up this mess. Like terms, so that's going to be the x squared. Basically, everything in red should cancel. Everything that you're subtracting should cancel. If it doesn't, then you've messed up somewhere. Everything after the subtraction sign should cancel every time when we do these. So I still have 2xh. I have h squared, and I have minus 5h. What do you notice about all three of those terms?
Have an H in it.
They all have h in it. So I would have h times 2x plus h minus 5 over h. Guys, the entire review will be up in Canvas. Please let me know over the weekend if you have any questions whatsoever. Send me emails, send me questions, send me Canvas messages. We will not have time to study before the test on Monday.